Hello students. In this video we're going to go over some examples from section 5.3 on normal distributions, and the topic is finding values. Okay, so in section 5.1 or 5.2 we found areas or probabilities inside the normal curve. And we did this by finding the area inside the normal curve to the left of a value, to the right of a value, or between two given values. So in this section, we're going to go backwards. So we're going to be given an area or probability inside the curve, and we're going to be asked to find the corresponding value or values. We will still use the normal distribution calculator in StatCrunch to do this. Alright, and you'll see exactly how this works when we do the examples. Okay, so let's briefly go to the textbook here. Okay, so the textbook begins section 5.3 by discussing the z-scores. Okay, and they start with an example of finding an unknown z-score from the standard normal distribution. So for example, in question 1, in example 1, on page 252, it says that we want to find the z-score that corresponds to a cumulative area of 0.3632. And they describe how to do that by using the normal distribution table, the standard normal table. Okay, so we're not going to be using the table, we're going to be using the normal distribution calculator in StatCrunch. So let's go ahead and look at our first example from homework. Alright, and it says we're going to find the indicated z-score in the graph shown to the right. So we have the graph of the standard normal distribution. And we know that this is the standard normal distribution because along the horizontal axis we have the z-scores. Okay, so we want the z-score with an area of 0.2389 to its left. Okay, so we're given the area to the left of the unknown z-score, and we're going to go find this unknown z-score. Okay, and you can see in the diagram that this z-score is to the left of 0, right? So here's 0, which is in the middle of the curve. Okay, so any number to the left of 0 on a number line is going to be negative. So you know that this particular z-score is going to be negative because it's to the left of 0. Okay, so any number or z-score to the left of 0 is going to be negative. Okay, so we're going to take this area of 0.2389 and input it into the calculator in StatCrunch, the normal distribution calculator. Okay, so remember when you're finding unknown z-scores, from the normal distribution the mean is 0 and the standard deviation is 1. Okay, because the given area is to the left, and we're going to select the less than or equal to symbol. Alright, and we're going to type the probability in this box. Okay, so what's going to happen is once we delete that 0.5 there and input the probability of 0.2389, okay, the unknown z-score is going to appear in this box. Okay, whereas before, right, we input the mean and standard deviation, selected the appropriate inequality symbol, and then typed in the value to get the probability. But in this case, right, we're going to go backwards. We're going to input the probability first, and then click compute to get the corresponding value. So this is the probability to the left of the unknown z-score. Click compute. Okay, and you can see that this diagram roughly looks like the diagram of the problem. Okay, it's the same area to the left. Okay, and it's telling us that the z-score is this number here. Okay, and we're going to round that to 2 decimal places. Okay, so negative 0.709. So that 0 there will get rounded up to we'll get rounded up to 1. So this is negative 0.71. Okay, so the z-score with this amount of area to its left is negative 0.71. Okay, let's try the next one. Okay, so question 2 says find the indicated z-score shown in the diagram to the right. Okay, so here we have our standard normal curve. The mean is 0, standard deviation is 1. Okay, so we can see that this unknown z-score is to the right of 0, so we would expect it to be positive, right? Your answer should be a positive z-score. Okay, and the amount of area to its right is this number here, 0.0869. Okay. So let's go back to our calculator. Okay, so the only thing we're going to change is the direction of the symbol. And then we're going to input the new probability, so 0.0869. And then when we click compute, the z-score will appear in this box. Because the given area is to the right of the indicated z-score, right, that's why we're selecting the greater than or equal to symbol. Okay, so click compute, and we get the same diagram that's in the problem. Okay, and we're going to round our z-score to 2 decimal places, so it's 1.36. Right, it's a z-score with an area of 0.869. So let me kind of update that, so 0.869. Right, so 1.36. So the unknown z-score with an area of 0.0869 to its right is 1.36, and it's positive just as we expect. The next problem we're going to look at is question 3 in the homework. It says to find the z-scores for which 70% of the distribution's area lies between negative z and z. So for some of these problems, you're not going to have a diagram to go by. Okay, but thankfully you can easily draw your own diagram to help visualize what you're asked to find and what you're given. Okay, so you can ignore the links here that say to click on page 1 or click on page 2 of the table. So we're not going to be using the table. We're going to be using the normal distribution calculator chapter. Okay, so let's go and look at a diagram of what this problem is asking us to do. Okay, so here we have our normal curve. Right, and whenever you're asked to find an unknown z-score or unknown z-scores, right, it's the standard normal curve whose mean is 0 and standard deviation is 1. Okay, and the area between the two unknown z-scores is 70%, and when you convert that into a decimal, it's 0.70. Okay, and remember to convert a percent to a decimal, divided by 100. Okay, so 70% of a decimal is 0.7 or 0.70. Okay, so that's the area between the two z-scores, and the reason that the diagram looks like this is because the problem said that we're finding the z-scores for which 70% of the area is between the two. Okay, so it's understood that when the given area is between two z-scores, okay, the area is in the middle of the curve, and then the two z-scores are the same distance from the mean. Okay, so this z-score over here on the left, right, is the same distance from the mean as this z-score is on the right. Okay, so the diagram looks symmetric. All right, so what we're going to do is on our calculator select the between option. Okay, the mean and standard deviation stay the same. Okay, and we're going to input the probability, okay, which is 0.70. Okay, and the two z-scores will appear in the boxes here. Okay, and as you can see, one is negative, the other one is positive. Okay, so the diagram here looks like the diagram we drew in our picture. Right, the area in the middle between the two z-scores is 70%. Okay, and according to the calculator, right, one of the z-scores is negative 1.036, and then the other one is positive 1.036. So it works out for this type of problem that the z-scores are the same value, but one's positive, one's negative. Okay, we're going to round these to the 2 decimal places. Okay, so the negative z-score is negative 1.04, and the positive one is 1.04 as well. Okay, and I think you can enter them in any order, so 1.04, comma, negative 1.04, as long as you separate them with a comma. Alright, good, so we answered question 3 correctly. Okay, so question 4 is more of like an application problem. Okay, so it says that in a recent study on world happiness, participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 represents the worst possible life, and 10 represents the best possible life. The mean response was 5.3 with a standard deviation of 2.3. Okay, there are 3 parts to this question. Alright, so in part A, we want to find the response that represents the 87th percentile. Okay, so once again, part A says what response is at the 87th percentile. Okay, so before we answer the question, let's do a quick review of what a percentile is. So the percentile of a data value indicates the percent of data values that are less than or equal to it. So for example, a data value at the 5th percentile means that 5% of the data values are less than or equal to it. So likewise, a data value at the 82nd percentile means that 82% of the data values are less than or equal to it. Okay, notice that in my definition of percentiles, right, it says less than or equal to that data value. Okay, so for the problems in this section, percentiles usually mean that the area is to the left of the unknown value. Okay, so you want to be sure to convert the percent to a decimal before inputting it into the normal distribution calculator in StatCrunch. Alright, so let's see how this would look. So in part A, we want to determine the response at the 87th percentile. Okay, so what that means is that this unknown value, right, will have an area of 87% to its left. Okay, so try to picture what that looks like. So try to picture a normal curve with an unknown value, and then the area to the left of that value is 87%. Okay, so 87% is a decimal. It's 0.87. Okay, remember the mean of the curve is 5.3 with a standard deviation of 2.3. Okay, so we're going to go back to standard. Right, since the given area is to the left of the unknown value. Given mean 5.3, standard deviation of 2.3. Okay, so since percentile indicates an area to the left, then we're going to change that to the less than or equal to symbol, and then input the area to the left, so 0.87. Okay, so the response on that survey that's in the 87th percentile, okay, would be, if we round that to 2 decimal places, would be 7.89. Okay, so 7.89 is at the 87th percentile on the World Happiness survey, so 7.89. Okay, so what that means is that about 87% of the respondents, right, will respond with a 7.89 or less on the World Happiness scale. Okay, so part B says what response represents the 61st percentile. Okay, so the only thing that we're doing different is changing the area to the left. Okay, so because it's talking about a percentile, we're still going to use the less than or equal to symbol. And we're going to change that area to 0.61. So 61% is equal to 0.61. Okay, so the response is a little lower, right, because the area to the left is lower. Right, so the response on this happiness scale at the 61st percentile would be 5.94. Okay, and essentially what that means is, if the mean is 5.3 and the standard deviation is 2.3, and these and the responses on the survey are normally distributed, okay, what that means is that 61% of the respondents will score or will respond with a 5.94 or less. Okay, let's look at part C. So part C says what response represents the first quartile. Okay, so you can think of the number 1 followed by ST. Okay, that's what first means. So first percentile means is that the area to the left of that unknown value is equal to 1%. Okay, so 1% as a decimal is equal to 0.01. Okay, and again, the area is still to the left because it's a percentile, so we're going to change this area to 0.01. Click compute. Okay, and it's giving us a negative value. Okay, so I think I misread the question. It says the first quartile, not the first percentile. So the first quartile is the 25th percentile. Okay, so this should be 0.25, not 0.01. So 25% of the decimal is 0.25. Okay, so the response at the first quartile, or the 25th percentile, is 3.75 when you round it. And that completes question 4. Thank